Masterpiece of gravity. Gravity is very important to us. We could not live on Earth without it. The Sun's gravity keeps Earth in orbit around it, keeping us at a comfortable distance to enjoy the Sun's light and warmth. It holds down our atmosphere and the air we need to breathe. Gravity is what holds our world together. In this video, we will talk about gravity, the masterpiece of nature. But before we begin, please like and subscribe to our YouTube channel for such amazing and informative videos. The traditional scientific approach to investigating the role of a variable on a living organism is to either remove it or assess the ability of the organism to sense it. Gravity is no exception. Access to space has made it possible for us to begin the exploration of how gravity has influenced our evolution, our genetic makeup, and our physiology. Identifying the thresholds at which each body system perceives how much, how often, and how long the gravity stimulus is needed and in which direction it should be presented for maximum effectiveness is fundamental knowledge required for using artificial gravity as a therapeutic or maintenance countermeasure treatment in exploration missions. Here on Earth, although surrounded by gravity, we are negligent in using gravity as it was intended to maintain the level of health that is appropriate for living in 1G. These changes in lifestyle or pathologies caused by various types of injury can benefit as well from artificial gravity in much the same way as we are now considering for astronauts in space. In the late 1600s, Isaac Newton introduced his law of gravity, which identifies gravity as a force of attraction between all objects with mass in the universe. The law also states that the strength of gravity between two objects depends on their mass and distance apart. Newton's law of gravity was accepted for more than 2 centuries. It can predict the motion of most objects and was even used by NASA to land astronauts on the moon. It's still used for most practical purposes. However, Newton's law doesn't explain why gravity occurs. It only describes how gravity seems to affect objects. There are also some cases in which Newton's law doesn't even describe what happens. In the early 1900s, Albert Einstein came up with a theory of gravity that actually explains gravity rather than simply describing its effects. Einstein showed mathematically that gravity is not really a force of attraction between all objects with mass, as Newton thought. Instead, Einstein showed that gravity is a result of the warping or curving of space and time, which make up the same spacetime fabric. These ideas about spacetime and gravity became known as Einstein's theory of general relativity. Gravity is one of the most fundamental forces in the universe, and it has fascinated scientists for centuries. It is the force that governs the motion of planets, stars, and galaxies. And it plays a critical role in the structure and evolution of the universe as a whole. Throughout history, many great minds have contributed to our understanding of gravity, from Galileo and Newton to Einstein and beyond. However, perhaps the most significant masterpiece of gravity is the theory of general relativity. General relativity is a theory of gravitation that was developed by Albert Einstein between 1907 and 1915. It describes gravity as a curvature of spacetime caused by the presence of massive objects. In other words, it suggests that massive objects like planets and stars distort the fabric of spacetime around them, causing other objects to move in certain ways. The theory of general relativity is a beautiful and elegant concept, and it has numerous implications for our understanding of the universe. One of the most important of these implications is the prediction of the existence of black holes. According to general relativity, if a massive object is compact enough, it can create a gravitational field so strong that not even light can escape from it. This phenomenon is known as a black hole, and it has been observed and studied extensively in recent years. Another significant prediction of general relativity is the existence of gravitational waves. According to the theory, when massive objects move, they create ripples in the fabric of spacetime that propagate outward like waves. These waves were first detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO, opening up a whole new field of astronomy and providing a new way to study the universe. General relativity has also had a profound impact on our understanding of the nature of time and space. According to the theory, time and space are not absolute and separate entities but are instead intertwined in a single, 4-dimensional fabric known as spacetime. This concept has had far-reaching implications for our understanding of the structure and evolution of the universe, from the behavior of black holes to the origin and evolution of the universe itself. Einstein derived his theory using mathematics. However, you can get a good grasp of it with the help of a simple visual analogy. Imagine a bowling ball pressing down on a trampoline. The surface of the trampoline would curve downward instead of being flat. Now imagine placing a lighter ball at the edge of the trampoline. What will happen? It will roll down toward the bowling ball. This apparent attraction to the bowling ball occurs because the trampoline curves downward, not because the two balls are actually attracted to one another by an invisible force called gravity. Einstein theorized that the Sun and other very massive bodies affect space and time around them in a way that is similar to the effect of the bowling ball on the trampoline. According to Einstein, objects move toward one another because of the curves in space-time, not because they are pulling on each other with a force of attraction. Einstein's theory is supported by evidence and widely accepted today, although Newton's law is still used for many calculations. Newton's law of gravity can predict the motion of most but not all objects. It also doesn't explain gravity. It only describes its effects on the motion of objects. Einstein showed mathematically that gravity is not really a force of attraction between all objects with mass, as Newton thought. Instead, gravity is a result of the warping of space-time. Einstein's ideas have been supported by evidence and are widely accepted today. According to Muriel Ross, neuroplasticity, the ability of the brain to learn from experience and adapt to new environments, is recognized as profound, and exposure to altered gravity has an effect on communication sites between the sensory cells in the nerve fibers ending on them 30. This could lead to the assumption that similar exposure to a force greater than 1 gram on a centrifuge on Earth might one day prove useful in restoring a sense of balance to disabled people who have lost it. There are cases of children with medical disorders, such as autism, attention deficit disorders, Fragile X syndrome, etc., who have sensory modulation problems, such as the inability of the nervous system to continually and accurately register sensory information. The causes of these disorders are not well known. The problem in this case is that the child's nervous system is not modulating the sensory input successfully and is not responding to the sensory information appropriately. A brain damaged at birth may require hypergravity, a higher intensity of gravity stimulus, before a child's brain becomes programmed to respond to direction and acceleration and eventually learn to walk. Increasing gravity could modify or alter his perception of it prior to responding by triggering gravity sensors and brain blood flow. This would mean that rehabilitation exercises in children with cerebral palsy should be more effective if done in the upright position in a way that the body may experience some load, even if the child has to be supported by a harness. Alternately, the movement therapy could be done on a centrifuge. Furthermore, by identifying the thresholds at which each body system perceives how much, how often, and for how long the gravity stimulus is needed, and in which direction it should be presented for maximum effectiveness. Using hypergravity might be proved to be a potential new therapeutic approach for children with disabilities and the elderly, adding another terrestrial application of space research. Did you learn something new about the masterpiece of gravity that you didn't know before? We hope you did. So, if you're interested in learning more amazing knowledge about science like the masterpiece of gravity, make sure to subscribe to our YouTube channel and hit the bell icon to get notified of our new videos. Please like and share the video. Don't forget to comment your views on this. Thanks for watching to the end.